G'day guys, Alan here. Welcome back to my workshop and the continuing journey of my Lynx15 engine. In this episode I focus on the valve train, so valve guide, valve spring retainer and the tappet. And these are all tiny little pieces, as you can see, about the size of my little fingernail literally. And there's a lot of very small scale features, 0.5 mm wide slots and such. So very challenging for my old eyes. But it makes for a lot of detailed lathe work, which I hope you'll find interesting to watch, and some challenging setups as well. Anyway, let's get into it and I'll show you how I went about it. So I'm making the valve guides now, and these are to be a press fit in the cylinder head. And there are 3 external diameters to get correctly sized. The one that will do the lion's share of the lifting when it comes to being the press fit in the head is this guy. It's nominally 10 mm. But to get the press interference that I wanted, I need this to be 10.01. I got pretty close to that. So 10.012 for that, that's pretty good. Right, so I'll part this thing off about 0.3 or 0.4 long. So when I turn it around in the chuck, I've got something to face off to length. Right, well that turned out alright. So put him back in the other way around, face the back off. So we're going to turn around in the chuck, and so now I'm going to do the final facing cut here to reduce this the length of this diameter to 1.5. Okay, so this guide has to have 2 bores. The major bore at this end is basically part of the port to allow for gas flow, and that's 8 diameter, and then the second part of it is a much smaller bore, 3 diameter, for the valve stem. So we'll go in first up, obviously, and open it out for the larger diameter. We'll speed it up a little bit. So I think that'll do for that. And we'll go the rest of the way through and out the back with 7/64 to make way for the 3mm reamer. Hopefully that won't wander too far off course. I could kick that up to 2000 RPM. This chuck is rated for 2500 RPM, so perhaps I will go to 2000 for this small drill. It's a little bit daunting when it kicks in, but there we go. Okay, and through. Now let's get this board out to 8mm. Alright, this could be the last pass. We're going for 8 this time. And let's start off and see whether the 8mm dowel pin will go in. It will, but it's a little bit tight, so I think that's just fine. The next thing is to get a tiny little chamfer on the bore, and that will be the valve seat. It's supposed to be 0.2mm wide. Yeah, right. Well, I can't even see that sort of scale, but I've got to come up with a way of getting such a fine chamfer. Right, well, we're set up to move in at 45 degrees. I guess we'll keep going until I can see something. Alright, we've just made contact with that corner. So now I've got to work out how much further to go to get my point 2. So according to my maths, I've got to come back this way, 0.14. Let's come back 0.1, at least I can see the beginning of a chamfer. So we'll go 0.14. Now I dare say you can't see that, but there is a small chamfer there. Done about 0.2. This is the issue I have with the Webster engine. The valve seat is so narrow, in my old eyes I can hardly see it, and I don't know what you'd measure it with. But I can see it, and I don't know, it looks like it's a bit less than 0.5 millimetre. So I think we'll call that done, as I'll be lapping the valves into it anyway. Only thing left to do now is push the reamer right through. Done. So I'll just get a 3mm pin. It's a nice sliding fit in there. I'll get a bigger pin, see how much clearance there is. So this one's 1/1000th of an inch over. Yeah, that's tight. So back to the one that's on size. Yep, happy with that. So that's finished this guy. We'll have him out. And clean that burr up on the back. And he's done. So I don't know how well you'll be able to see that, but there's a test fit of the guides in the cylinder head to make sure that the major diameter on the lip will fit into the recess in the head, and they both fit in beautifully. It's just quite a snug fit, so they won't fall out, but they're just perfectly located there. So very happy about that. So I've moved on now to turning the valves. And yeah, I'm a novice at this, so I'm not really sure what I'm doing. So it's got to be made out of stainless steel, so I've roughed it, as you can see. Basically it's about 30mm long with a 10mm OD on the end and 45° chamferish there. So one thought I had was to machine this to the correct OD and leave it long, and then move the whole thing further back in the chuck, so they could have a groove in the end here. And I'm not sure how I was going to do that, so I've made up this collet which will allow me to in fact put this on size at 3mm, mount the whole thing further back in there. So what you see here is my homemade split collet. It's mounted in a 10mm ER40 collet, and that's a 3mm gauge pin. So having made this collet, I wanted to see what the run out was, because a collet in a collet isn't an ideal situation by any means. But I was actually quite surprised, as you'll see. So up close to the chuck, I've got to run out of about 1/1000th of an inch, and 20 or 30mm away, that increases to 2 or maybe 3/1000ths. But that's going to be fine for what I want to do, which is just finishing off the machining on the end of the valve stem, and I will be able to do that close up to the chuck. So that's a good result. But I'm not sure whether I'm going to use it. We'll see. So I've got this down to 4mm. There's also supposed to be a radius here. I'm not sure I'm going to do that yet either. Anyway, I'll bring it down to, bring this piece down to 3, I think, and we'll take it from there. So in this pass, I'm going to go down to 3.5. And make sure I'm not touching my centre there. 3.2. 3.24. I can't get it on size. 3.24. Still oversized. 3.13. 3.15 there. I think I'll do another pass at 3.1. 3.128. Well, I can't get it on size. Well, we'll leave it there for a moment. I'll have a go at doing this radius here. So we're going at 3.1 here, which should be about where that is. Well, that seems to be working out all right. What I'm going to do now is get the final diameter right. Alright, so let's try doing a pass at 3.05 full length. Oh, a terrible surface finish there. Well, after a bit of fiddling around and fine tuning and using emery paper, fortunately, because this valve stem was slightly oversized, I could clean it up with the emery paper, and it seems to have come out all right. This is still quite a close fit on there, but I think there should be enough clearance there. And right, so I was able to use that button insert tool to create a nice rounding in the, is that the neck or throat or whatever of the valve? I don't know what the correct term for that is. Just call it the throat, I don't know. So now I just have to part it off and then do the features on this end. Okay, so now the feature that I have to put in here is a groove for some sort of retaining clip. The groove is 0.5 millimeters wide and 0.3 deep, which is a bit of a struggle for me, but you might be able to see I've actually ground a special grooving tool from an old hacksaw blade. That's actually a hair under 0.5 wide. So I'll plunge in 0.3 and use a feeler gauge to see just how wide the groove is. My head's probably getting in the way, but with the headband magnifier on, I can see that's actually 0.45 is a good fit there. Clumsy as well as blind. That's it. That's actually quite a good fit, amazingly. So after all that fruiting around, I've finally got it 0.5 wide. Oh, thank goodness for that. Right, so all I've got to do now is part this thing off and then cut it to length. Right, well there it is. I feel like I made a bit of a dog's breakfast out of making this valve. Hopefully the next one will go a bit more smoothly. If it does, I might even make 2 more and throw this one away. But anyway, I'll finish it out, so I've got to clean that face up and then chop the tail off to length. there should only be that groove should be 1 millimetre from the end of the stem. So put the valve in the other way around now so I can trim it to length. Right, so I've got it back in my split collet, and I thought I'd better just check to make sure the run out hasn't gone stupid on me. And now I'm still at about a hair over a thousandths of run out, so that's fine, because all I'm trying to do here is part that off. So if it's slightly off centre, it isn't going to make any difference. That's why I was keen to do that groove though, while I still had the original setup, so that groove is concentric to the shaft. Have to face off 0.1 of a millimetre, not 1. Right, so that split collet actually worked out pretty well. I'll be using it, I think, for the next valve. So there's the valve in its seat. You see it moves freely. There's almost no movement at all there. So I think that's going to work out just fine after a very wobbly start. So I'm just roughing this down at the moment. I'll have to change over to another insert shortly. I think we'll call that it. Alright, so now I've got to do the groove for the retaining clip and then part it off. And you can see in this picture, which was taken with a bit of magnification, that I did in fact manage to get the retaining clip groove on 0.5 millimetre and position it 1 millimetre away from the valve stem tip. So it was a bit of a struggle, but I got there. So I've moved on to doing the valve retainers. The material is brass, and these are very simple. There's just 2 or 3 diameters in a hole. Yeah, so I'm just roughing the material down. The OD of the finished part, the major OD is 9.5, so that's what we're shooting for on this bit of stub. But shooting for 10 on this pass. So the trouble with machining brass is it sprays everywhere. Anyway, I'm still calibrating the DRO for this piece of material, so let's see how close we got to 10. .007. Right, so we're obviously pretty close to 10. So let's go for 9.5, and I think we'll be just slightly over. I don't think this OD is at all critical, because these just have to fit inside the tappets, which have a 10mm bore, so there's plenty of room. Anyway, we'll shoot for 9.5. I don't know whether we'll hit it. Anyway, we'll see. .508, well that's close enough. Like I said, this is just into space, it doesn't match to another part, so 9.508 is fine. Okay, so that's the major diameter sorted. Now we'll start doing the bore. So I'm going for the final pass here, 5mm diameter, 0.8 deep. Alright, let's see if we've got 5mm. And I bought this inside micrometer just recently. I saw it on special and I thought I would go for it. Oh, I guess we're on size or in size. Okay, 5mm. Now I have to machine it with a shoulder behind this front face. So that's where I parted off. Let's put a catching stick on there. Oh, and that's the first one done. Just got to clean that little bit off. Just by squeezing that. God, where's that gone? Dive straight for the biggest pile of shavings it could find, of course. Alright, so that bit's broken off. I just have to get rid of that burr now and call that done. So I've moved on to making the tappets. They've got to be made out of aluminium bronze, so I'm roughing this piece of bar stock down to about 13mm, and I'm using a different tip. And I'm actually really surprised at the surface finish and also the way the chip comes off, as you'll see. That was a 1mm depth of cut, taking 18 down to 16, and that's amazing, and I was really pleased with the chip. So I'll be using that one for this job. I'll be using this tip for this job. I'm going to start reducing the depth of cut now from 1 to 0.5. So we're shooting for 13 this time. Let's see what difference changing the depth of cut made to cutting on size. 13.01, right. So this would be my final pass at 12.5. Alright, let's see how close we got to 12.5. Well, I'm going to call that close enough. More importantly, whether this outside diameter will actually fit into the bore in the cylinder head. So 12.5 is what it calls for in the drawing, but the question is what sort of fit do we get in the bore? And I don't know whether that might well be. I think that's probably just a bit too tight, as it is supposed to go up and down with the valve. So free that up a little bit. What about the other hole? Yeah, pretty much the same story. Slightly tighter actually. Let's give this a go with the Scotch-Brite. See what difference that made, if any. I don't know whether that's too tight or not. But the other hole. Slightly looser in that one. Alright, I'm going to call that perfect for that one, so We'll part this bit off and then worry about the rest of it for the other hole. Of course, I'm getting ahead of myself. I've got to bore it out first. I should be able to clean a bit more out with this guy and leave a flat bottom in the hole. That doesn't feel fantastic. I think I just used the boring bar. I didn't like the amount of pressure I was putting on to get that cut. Righto, this is the final bore. I don't know that this is particularly critical because I think it's just clearance for the valve spring. But we'll still give it our best shot for hitting 10. And we'll see what this fellow says. Well, within the limits of the accuracy of this thing. That's saying we're right on 10. See if I can find a 10mm dowel pin and check it that way. Right, 10mm dowel pin. He would press in without any trouble, but I think that's going to be close enough to 10. So I'm going to part this off now with a 0.1 allowance for facing the back side. Ah, there we have him. Let's clean the back up and make the other one. Well, as I said at the start, making those bits was quite a challenge for me, my old eyes, but I stuck with it and got there. Hope you found it interesting watching that, maybe got some ideas for how you might do similar. If you've got better ways, or you're sitting there looking at it and thinking, why is he doing that? Do it this way, it'd be much better. Please leave a comment. I'm happy to take suggestions on board, and especially if they make my life easier, I'll be quite thankful. In any case, thanks very much for watching, and I look forward to seeing you in the next one, where I start tackling the cam box, I think, and that'll be a slightly larger scale piece, so hopefully a bit easier for me. Anyway, cheers.